Okay, Assalamualaikum warahmatullahi wabarakatuh. We are from group 5. We want to present about our slide in experiment 2, which is flow measurement. So our group is myself, itself, Lukman Hakim bin Muhammad Jalaluddin, Muhammad Ifar bin Mokhtar, and Mubarak bin Muhammad Bakri. So the first one is abstract. So the abstract in the experiment is flow measurement has become a crucial factor to consider as the transportation of fluids and supply has progressed. An experiment is conducted to compare the discharge coefficient of different types of flow measurement methods. Then the accuracy of the flow meter were determined. This experiment is conducted by connecting the tubes with flow meter, then record the data into the tables. After that, we replace the flow meter with other types of flow meter. In this experiment, in order to get the result, we use the derived discharge coefficient values. Then we compared the accuracy of each flow meter and came to a conclusion as to which flow meter would result in higher accuracy. Due to the minimum energy loss in operation, the benchmark meter has proven to be the most efficient flow meter in the industry, followed by nozzle, and the last one is orifice plate, which is the least efficient out of all the flow meter. Okay, for the objective in the experiment is to compare and contrast the discharge coefficient of various types flow measurement methods. For the introduction in this experiment is flow measurement is an important aspect of fluid dynamics research. It must be used in chemical facilities, refineries, power plants, and anywhere else where precise flow rate is required for product quality or facility performance. Flow measurements are also used in the metering of water into our houses and gasoline into our automobiles. In this experiment, 3 widely used flow meters will be used, which include venturi, orifice plate, and nozzle. The properties of the fluid flowing through pipes are frequently dissimilar. As a result, various measurement principles are required. Flow measurement using the difference pressure principle is one of the methods. This method for measurement is significant since it aids in system analysis in terms of consumption and leak detection, as well as lowering energy usage and cost. Bernoulli has discovered the relationship between the pressure and velocity of a fluid flowing in a pipe, whereby an increase in velocity results in a decrease in pressure. Okay. Wabarakatuh. My name is Lukman Hakim bin Muhammad Jalaluddin. So I want to present about my part, which theory and methodology. So in theory, in fluid dynamics, Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in static pressure or a decrease in the fluid's potential energy. The principle is named after Daniel Bernoulli, who published it in his book Hydrodynamica. Therefore, in this experiment, we use 3 common types of flow meters, which orifice plate, venturi, and nozzle. First one is orifice plate. An orifice plate is a thin plate with a hole in it, which is usually placed in a pipe. When a fluid, whether liquid or gases, passes through the orifice, its pressure builds up slightly upstream of the orifice. But as the fluid is forced to converge to pass through the hole, the velocity increases and the fluid pressure decreases. A little downstream of the orifice, the flow reaches its point of maximum convergence, the vena contracta, where the velocity reaches its maximum and the pressure reaches its minimum. Beyond that, the flow expands, the velocity falls, and the pressure increases. By measuring the difference in fluid pressure across tappings upstream and downstream of the plate, from Bernoulli's equation using coefficient established from extensive research. So, the Bernoulli equation can be applied with the assumption of the flow is horizontal, steady, inviscid, and incompressible. The equation for theoretical flow rate can be expressed as the following. Okay, the second is nozzle. The nozzle apply the same principles and calculation as orifice plate, with only changes on A2, which is cross-sectional area of nozzle. The difference between them is only the shape of the restricted opening, whereby the nozzle as shown in figure 3 is approximately a quarter ellipse. And the last one is venturi. The venturi consists of a rapidly converging section which increases the velocity of flow and hence reduce the pressure. It then returns to the original dimension of the pipe by gently diverging the diffuser. Pressure difference, the discharge coefficient can be calculated. This is a particularly accurate method of flow measurement as energy loss is very small. Same principles and calculating as orifice plate apply to venturi, with only change in A2, which is cross-sectional area of venturi. So this is apparatus that you use in experiment, which multi-tube manometer, orifice plate or nozzle, water inlet, main switch box, flow control valve, venturi, sump tank, water outlet, gate valve, rotameter and ventilation valve, which black and white. Okay, we go through to methodology. So first one, the orifice plate was properly fixed and the manometer tubes, which H1 and H2, were fastened to the orifice plate. The second, the flow control and gate valves were closed, then the main switch and the pump were turned on. The third, the flow control and gate valves were opened slowly and simultaneously until they reached their maximum opening level. The fourth, the ventilation valve, which black, was opened by turning it to anti-clockwise direction to release all the bubbles in the system. The fifth, the ventilation valve, black, was closed, then as well as the gate valve. The pump was turned off. Then the ventilation valve, which white, was slowly opened until the minimum water level of 30-40 mm is reached. Then the pump was turned on. Then the gate valve was opened slowly until the level of water in H1 reached maximum 390 mm and manometer H2 is at minimum level. All the reading multi-tube manometer H1 and H2 and rotameter were recorded. All the reading multi-tube manometer H1 and H2 and rotameter were recorded for 5 different values of actual by adjusting the opening of the gate valve. Okay, next, the gate valve was closed and the pump was turned off. The manometer tubes was removed from the orifice plate. The orifice plate was changed with the nozzle and steps 1 to step 9 were repeated. Meanwhile, for the venturi, the manometer tube connected to H1 and H3 and similar step of 1 to 9 were applied. And then the last one, after finish, all the manometer tubes were removed from the system. The flow control valve was closed and the pump and the main switch were turned off.
Assalamualaikum. My name is Muhammad Irfan bin Mokhtar and I'm going to be presenting the results. As you can see, the results on the table, we have the flow rate of the rotameter, the volume, the time, the actual flow rate, the theoretical flow rate, height 1, height 2 of the manometer, the differential height, delta H, and the discharge coefficient, CD. And as we can see, we already calculated the theoretical flow rate from the equation using the differential height, and we calculated the actual flow rate, and from that actual flow rate and the theoretical flow rate, we got the discharge coefficient. And we can see in the first table, this is the table for orifice plate, and the second table is for nozzle, and finally the third table is for venturimeter. For the sample calculations, we put some examples of our calculations from how we calculate the theoretical flow rate, the actual flow rate, and the discharge coefficient. As you can see in the slides, we find the theoretical flow rate from the equation, and we find the actual flow rate from the volume and the time, while for the discharge coefficient we use the ratio of the actual flow rate and the theoretical flow rate. For the discussion part, the factors contributing to errors or inaccuracy in experiment data and the possible recommendations to improve the existing results. There were errors that might contribute to the accuracy of the experiment, which is the first type of error is systematic error, which is parallax error, where it occurred when the eye is not perpendicular to the scale, which causes it to be read wrongly. And the best way to improve the result is to have the eye to be perpendicular to the scale and reading the scale carefully. And other major causes of inaccuracy would be ugly piping or roughness and valving. Ugly piping is bends in the pipe or partially open valve, reduces expanses that can cause severe disturbance of the flow. And the wall roughness, the condition of the pipe can affect the quality of the flow in the flow meter, for example, like wall friction. And for valving, if a valve is partially closed, it can result in a distorted flow, and it can cause a large measurement error. The second discussion, which is the differences in discharge coefficient value for each of the flow meter and the ranking of the flow meter according to their accuracy. And the discharge coefficient, or also known as coefficient of discharge or efflux coefficient, is the ratio of the actual discharge to the theoretical discharge. There are standards CD of each flow meter, such as for venturimeter it is 0.9, for orifice plate it is 0.6, and for nozzle it is 0.97. But the value varies noticeably at low values of the Reynolds number. To identify the accuracy is the percentage error, where it is accepted value minus the average experimental value over the accepted value times 100%. For the conclusion and recommendation, one of the many recommendations to improve the result is making sure the flow meter is installed properly, calibrating the flow meters, making sure there's no defects or bends in the pipe, installing the pipes in a way to avoid bubbles, making sure the measuring fluid is a single-phase fluid. For the conclusion, we can conclude that the accuracy of the flow meters are affected by the discharge coefficient of each flow meters respectively, and as the differential pressure drops, increases, the theoretical flow also increases, and this proves the principle of the Bernoulli equation, where the velocity increases as the pressure decreases. And based on the objective of this experiment, the coefficient of discharge CD of the different value of the different flow meter varies, and with the venturimeter being the most accurate, followed by the nozzle, and lastly the orifice plate. And the most accurate device will have the least pressure loss. Thank you.